Okay, this is another example of how can we use the Gauss law in a different way than we have done before. Before we have used Gauss law to calculate flux, to calculate charge. But what about we want to use the other section of the Gauss law? The full Gauss law states flux equals to closed integral surface of flux density times ds, which is going to be equal to q. Till here we have used it. What about the other section that says that the integral volume of rho b times dB? That means if we know the flux, we know the flux density times ds and the integral of that. We know the surface charge and we can know what could be the volumetric charge distribution for any radius. And that's the one thing that we're going to calculate now. For that matters, we will only use these two sections, these two sections. And we will take advantage of what we have seen before. We know that the result of this integration is actually going to be this thing that we can fix a little bit again. This is going to be 4 pi, and this is going to be equal to flux, and this is going to be equal to closed integral surface of this. So we already know the answer for the left part of the expression. We'll just take it and save it for later over here. So we gotta work now with this part. It's going to be a volume integral. That means integral, a triple integral of rho b times d, not ds, but dB. And if we remember, the dB for spherical coordinates is going to be r squared sine of theta dr d theta d phi, just like that. So we take this value and we just place it, and what we do, and we just place it in here. We erase this, we just place what we just copy in here. So the triple integral is going to go first one for the dr, second one for the d theta, and third one for the d phi. For the dr, we're going to go from a radius of 0 to r. For the theta, we're going to go from 0 to pi. And from the phi, we're going to go from 0 to 2 pi. Something like this. Now, here, the only thing that's going to be kind of constant, we can assume it's going to be rho b. So rho b, can we take it out of the equation and place in here? So we have to evaluate the integration of these things. We'll start with the easier one. The easier one, this one, t phi, because it's going to be about only about itself. So the integration of this will become rho b equal integration 0 to r integration 0 to pi times r squared sine of theta phi evaluated from 0 on to pi because it's this result dr d theta. we can just leave it like that. It's not going to be affected by any other integration. So we can now integrate about the theta with these elements. That means the result will give me the integration of sine of theta from 0 to pi. The result is going to be looking like this: integration 0 to r of r squared phi from 0 on to pi, and the integration of this is going to be minus cosine of theta evaluated from 0 to pi dr. Finally, we integrate about dr in these limits. So this result is going to look like r cubed over 3 evaluated from 0 to r times phi evaluated from 0 on 2 pi times minus cosine of theta evaluated from 0 to pi. Now we have an expression for rho b, not necessarily from rho b. Remember, rho b it's not like that. Actually, rho b is going to be outside of this equation. Rho b should be here, right there. We can take this expression and start to evaluate within the limits. Eliminate all this part, take this one, and evaluate. So rho b is going to be multiplied times radius cubed over 3. If we evaluate that between 0 and radius, it's going to be radius cubed over 3. If we evaluate phi from 0 to 2 pi, the result is going to be 2 pi. If we evaluate minus cosine of theta from 0 to pi, the result is going to be minus minus 1 minus minus 1, which is going to become 2. So we erase this part and we just add times 2. We can agree so that rho b times radius cubed over 3 times 4 pi. It's going to be the answer for this integral. If the answer of this integral is going to be equal to the answer of this integral, we just equal them right here. We will have 0.3 times 10 at minus 9 radius 4 pi equals to rho b radius cube over 3 times 4 pi. From here, we see there are some elements that can be eliminated. For example, 4 pi and 4 pi. We just erase them because we got them the same in the both parts, so they become 1. Then we just start solving for rho b. When solving for rho b, we will have rho b equal to 0.3 times 10 at minus 9 times radius at 4 multiplied by 3 and divided by radius cube. If that's the case, I can erase these 4 and this one right here, and these 3 can be multiplying this one right there. So the result is going to be 0.9 times 10 at minus 9 radius, only that. And the result is going to be given in coulombs per cubic meters. That way, we can obtain my full expression of rho b. Rho b equals 0.9 radius nanocoulombs per cubic meter, which is the one thing being asked by the problem. There we go.